We can hand it over to Väino, who has, I think, been involved in the topic for quite a number of years, and he's involved in a very interesting project, and we are very eager to hear from you about your work. Väino, over to you.
Thank you. So nice to be able to present this. My name is Väino Tarandi. I'm professor in IT and construction. I live in Stockholm now and I've started my own consultant company, Tarandi AB, working with these kind of issues. And this project, the Testbed, smart planning, construction and facility management processes throughout the life cycle, started 2017 and ended 2019. That platform, it links various life cycle stages throughout the built society, and it supports level 3 of this BIM wedge, what you call it. And at KTH, I started this in the BIM lab already 2011 with some other collaboration hubs. And the testbed, the core values here are, can mention standard interfaces, REST APIs to access this, and also these heterogeneous environments map different data models to a common neutral structure according to PLCS, and also support for common data environment. And it supports an uninterrupted information flow. And for these digital twins and circular designs, there is a requirement for unique identities, classification, versions, associations between individuals and types, etc. So in the testbed, we merge geodata and BIM data with access to external databases and links there. We have done some test cases for these imports and exports. We have tested it for both the planning process for municipalities and industry. We have the construction process here and the planning process, having the testbed sort of in between. And the concepts are based on existing work practices here in Sweden. But the information flows have been extended and changed to really sort of taking the information the whole way and having the flow. But our test cases have been just parts of these. And in the next project, starting in this autumn, Testbed 3, we will try to have asset management, etc., the whole way and look at the process. And we have issues with these global unique IDs and these UUIDs on the municipality side, for example. And the use cases, we link some municipality planning and industry construction process. We have the architect's design model to production planned and realized models. We link buildings in a city model to the platform and vice versa. We have these 3D properties and the individual elements in the BIM models linked. And we link sensor data to the realized objects and then link to their design objects for the requirement values. We are looking at the different phases of the processes, like the Royal Institute of Building Architects. Here we follow that as an example, and we have ISO 12006-2 with the construction results and construction resources, looking at how you break it down into these construction products and so on. With these blue shades, we see the preferred phase and the level of detail here in the construction structure where the decisions are taken. And down here we have the PLCS entities, requirements, spatial elements, physical elements as planned and as realized. And these are the icons, and they are sort of decided here in the concept phases, and they are versioned. And here comes then the as planned in the tendering and product planning, and then the as realized one down here in at handover for the operation. And the use cases, 3D detail plan to design. Here we import the geodata building from the municipality into the platform and export it to the designer to do their BIM model, and then check the models for building permits, for example. We have the design plan realized for the architect. Here is the design that is imported, the as planned imported, and as realized imported, and then they are having their different representation in the different phases here. Then sensor data, link the sensor data and the sensors to the different objects in realized and operation, and link that data, and trace it back to the requirements via as planned and as designed objects to the requirements that have been linked here in the beginning. The topology for the use case is breaking down the country in the counties, municipalities, part of city blocks, and real properties, putting some abstract buildings there as placeholders for the geodata and the BIM data. And we have networks, and we have also 3D properties that are perhaps linked to the municipality, we don't know. And we have facilities and facility parts coming from Building Smart now. And in these we can have then roads and railroads, put the bridges and so on. And these are as designed, as planned, and as realized here. And this structure is as realized in the municipality and the planning phase. And the structure of PLCS, here are the basic object types with requirements in the functional breakdown, system breakdown, zone breakdown, physical elements, the parts, product as realized. We have the requirements, the tasks for maintenance and operation, and we have state definitions, state observed, all these things, classical PLM. And here we map IFC, CTGML, and InfraGML to this. And here's another view. We can see the product, the subclasses, requirements, parts, breakdown systems, interfaces, slots. They are all products. They have versions, and they have views, product definitions. You link observations to the individuals, and you have work requests and activities to sort of work with these. And the main structure in PLM PLCS are these. We have product as the generic entity, that is subclassed, as I said. It has versions, and it has view definitions. Here is an instantiation on the wall, version 1, version 2, architect's view, and also the structural view on the same version 2 here. We also have important structure elements, these relationships on the product level, on the version level, and the view level. And these relationships, they are having the parent to the child relation, and the effectivity with the start date and end date if they end and there are new versions coming. And proposed start dates can be to indicate a proposal in the future. And the version is never ended, but the relations can be ended. So when we navigate, it's on these relations, we look for them in time. In the platform based on ShareAspace from Eurostep, we have all the source systems and import to consolidation of data according to PLCS standard in the data store. We have business objects for this platform now with BIM entities, and we have REST API to go to the different applications, importing, exporting here, manipulating the data. We have a relationship between the representation of the design, and we have the types, also parts with versions, so the types are versions for the design elements, and we have the planned elements also having types and versions. We link the design elements to the as planned elements, and we can have the relationship chain from the physical design elements to the product as planned and the product as realized, where we can link the serial numbers. And here we have the manufacturer specific products and types, and here we have the generic ones that should also be in different BIM object libraries. We map the different heterogeneous data models to PLCS. We test with network models, IFC infra, done some CityGML or the Swedish representation of it. I hope to look at infra GML. We have the PLCS concepts in the test bed. The design elements here, walls, openings and doors, the relationships are classified as IFC relation. And when we import from some data model with road links and road ports, we map them to these design elements and classify them as road link and road port, and have the relationship classified as something like link port connection. And then we connect the view definition usage and classify it as a road access, for example, from a garage door to an entry to a road going out to the big road, for example. And here is the process that we will walk through now. The platform is available for development, experiments and tests. And here we go through the multi-house in Malmö, and the municipality model here at the top, the real estate here, and in the municipality planning. And here comes the geo data model, the sort of 3D detailed plan for this property. And then there are parts divided with version 1, and some of them will get version 2 later on. And the industry process with BIM models for cost estimation and building permits, and then production planning, and for operation facility management, the realized one. If we go down here, we can see that we break down the municipality planning with an abstract placeholder for the building on the plot, and then we have the design phase, and we have tracing back from the different to the previous phases. And here we have different versions. I will come back to that. And here we have new versions of the parts, and then we add the BIM model under this abstract placeholder building on the property, because we talk about the same building both for the BIM and the geodata representation. And then we can merge them and look at them together in the city model. And here we have the BIM for the planning, and here is the BIM model for the as realized phase. So we have the first version of the geodata building with some sub-buildings with the geometry. Effectivity is ended for this, and there's a new version with these 3 different sub-buildings, and coming new versions on them, and the older ones are sort of ended the effectivity. And at the same time we add the building in the BIM model with here just 2 stories shown, floor 15, 14, and there are then spaces and building elements under it. And then comes the as planned BIM model with also stories, and then you have the back tracing with identities on the different levels to be able to see what was coming before. And the 3D property in the as planned phase have some abstract stories to be able to link to spaces and building elements in different buildings on different real estates. In this table we have the municipality requirements, the as designed elements, as planned, where we have the suffix AP, and as realized with the suffix AR, to be able to differentiate them in the GUIs and other files, etc., where we see them. And now the demonstration part. We have the municipality here. We look at the queries. We ask for municipalities. We find Malmö here. Here are the results of the queries, and here are the details of these selected results. And we have the Malmö here, just a map to present it, and we have these 2 facilities, West Harbor and Central Station. and break down the different districts. Here is Limhamn Bunkeflo is one part here, and there is one 3D property and 3 real estates. And the 3D properties could be shown in 2 different places, but it's the same in only one instance in the model. From this Bryggan 1 real property to this multi-house, we navigate down there, and then we from that coordinate go out in the city model from Bentley Open City Planner and see this real estate, and can then link from the identity of that into the platform again and come up to this real property with this abstract house here as a child, and we have the abstract building here, and this sort of date is now changed. So we go to the design stage and the building is selected. We see all these buildings and the versions, version 1 and 2 of some of them, all created, and their versions are displayed. We set the date, and then we review this again, and we find that this abstract building has one geodata building, Swedish geoprocess building here, version 1, and it has a sub building part 4431 as we saw before, and here's the properties of that, the IFC model, and we export that IFC file with properties into Solibri, for example, to look at the building permit status and some dates and so on in this. Back to the Open City Planner, and now we have exported this geodata building, and we go back here and set the new date and select the multi-house again, this abstract building, and see now that it's version 2 on the geoprocess building, and it has the 3 subparts with version 1. We move in date again and look at them, and now we have version 2 on 2 of them, and we can check one of them having version 2 on the geometry and properties as one view taken out in Solibri Model Checker. Go back and look at it, export it with KMZ files, put it in the right coordinate in City Planner, and we can then see that the BIM model for cost estimation building permit on this Bryggan, it's here. It's also under this multi-house, the abstract one, with the geoprocess data model to version 2, and we can combine them and see that there are some parts of the BIM model outside the geodata model. We go forward to the production phase and open here floor 16, and we can see that there is a link tracing back to the design phase from this plan phase, and we open this floor 15 and see spaces and building elements. Select one, room 106, and we can see that is tracing back to the design version, and we can see that there is a requirement linked to that when we go to the design version, and that's a temperature requirement, and that is just a very simple example. We go to the life cycle stage as realized later on here, and we can then see For the same story 15 on the same room, that it has geometry, it has a tracing to the as planned, the previous phase, and it has also an observation temperature available here. And that observation is a vector coming from an IoT device like temperature sensor or an observation. And the Testbed 3, starting in August, it will integrate sensors and other IoT components in the information model. And it will have 4 test cases with asset management, sensors through the process, smart city and requirement management. I will be the project leader. It will be 3 years. And we will have this addition on the sensor side. We collect and transmit, process and store, and keep control over these analyses and link the results to different phases and to the sensors linked in the model, serving some of the systems or spaces, etc. Thank you very much.